Okay, ladies and gentlemen, let's get back to it. And by back to it, I mean let's start for the day. Welcome to another EECS 498 Game Engine Architecture lecture. Thank you for coming. There is less incentive to come now that the exam is finished, now that the assignments are done. Well, the auto-graded assignments in any case. But we are going to be talking about a very cool topic today, a topic that I think has supreme relevance to what you've done this semester. We are going to give you the key today to help you escape build system hell, okay? The industry does not enjoy using Make and Visual Studio and Xcode all the time, and I guess you didn't enjoy that all that much either, but I hope it was useful to you. At the very least, you now know that all of these different build systems, at least as far as C++ projects are concerned, they all kind of have the same questions that they want you to help them answer, okay? And they have different UI and a different UX, but they're all kind of the same at heart. Other people noticed this, and so the CMake project was born, okay? So CMake, don't confuse it with Make, okay? I was confused what CMake was for the longest time for that reason. It's not just a C implementation of Make. It is a new thing. Okay, so we're going to be talking about that today. Of course, you are in the middle of your custom feature this week, and if you haven't started on that yet, please do so. At least start thinking about it, because we do need to see significant progress on Monday. Okay, and you're going to be submitting a video demonstration on Monday, talking about a few different things. Everything you need for Monday's submission is in this milestone assignment spec, so make sure you give that a read if you have not. Before that, though, we have a fantastic game engine to show you. This is a game engine that is quite extraordinary because it's a game engine that you use for fun, and it's a game engine that you pay for, okay? Lots and lots of people paid, about $60, I think, on the absolutely dunked on Wii U game console. Okay, a lot of people actually bought the Wii U game console just for Mario Maker. It was one of the killer apps of the system. The Wii U, if you have not seen it, is a game console that looks like this. This kind of looks like a Nintendo Switch, a super successful, critically acclaimed game console that sold a bajillion copies, and might be getting a sequel console. Or might not. I don't know if that thing's going to end up coming out someday or what, but we'll have to see what happens. Maybe we'll all have to pitch in money to be able to afford one. We'll have to see what happens. But anyway, this, in some ways, was kind of the first attempt at the Nintendo Switch idea. Now, if you don't know, it came in two pieces. The console, and the controller, okay? And these things were not, you couldn't separate them, okay? You couldn't separate them like you can with the Switch and the Switch dock. If you moved too far away, like you took this into the bathroom, but you have this near your TV in the living room, it would start getting real choppy real fast. Because the way it worked is that all the processing would happen on the Wii U, and then it would use a local network to kind of beam the images and the inputs back and forth to the console where the actual display was. And this touchpad was almost always just about useless for anything other than managing an inventory or displaying a map, which both of those things have good solutions on normal consoles like the PlayStation 4. And so the Wii U gamepad was not super important. One way that it was extremely useful was with Mario Maker, okay? Because finally we had a vaguely laptop-ish touchscreen experience. And you could also be playing and dealing with one screen on the gamepad, whereas the TV held other information. So when you wanted to edit this Mario game, this level design, you'd beam it down to the controller where you could edit it very nicely. And then when you wanted to play it, it would beam onto the TV and you could have a great experience. So this is one of the few game designs, a hybrid Mario level editor / Mario game, where this console actually made perfect sense and was just about a perfect fit. Everyone thought Star Fox Zero was going to be the killer app, the reason to get this console. No, it completely failed. And only later on in the console's lifespan did it finally find a game that it should have shipped with. Okay, in fact, it should have been bundled with the console. Okay, it was that good of a fit. This could have been the game console where every other game for the console is like an editor. It's like a game engine game console. Okay, every game that comes out on it is a game engine and allows for heavy editing. You know why? Because that's what the Wii U is real good at. Okay, uniquely so. Anyway, this is famous, an engine. It came out in 2015. One of the more interesting things is that Mario Maker was made by the Animal Crossing team. And so one interesting thing from Animal Crossing is that it has, for a long time, had a retro game emulation within it. So in the Animal Crossing for the GameCube, you could play a lot of retro games. And so perhaps the team just really enjoyed that part of Animal Crossing and wanted to take their crack at it. Certainly, Animal Crossing is an extremely technically difficult game to kind of implement and organize. So if any team at Nintendo is going to be good at this kind of thing, the Animal Crossing team is probably not a bad choice. In any case, I want to show you the trailer for this game. Yes, this is one of our few game engines that actually has a trailer for it. Okay, so let's go ahead and take a look. This is Super Mario Maker 2, actually. So the follow-up. Nintendo is underrated for the way that they use music, even in their games, but in trailers as well. If you time if you time visuals to music, right, in the way this trailer did, everything has this feeling of polish and professionalism that you just cannot get from most normal trailers. In any case, you can see here that Nintendo basically takes their last few Mario games, even super new ones like Mario 3D World with the cat power-ups, and they basically say, hey, now you can edit it. And if you're a business person, if you are a producer at Nintendo, your eyes go the Wario gold dollar signs because you now have a repeatable, seemingly repeatable, we'll see how much they can squeeze it and milk it, but a seemingly repeatable business model where you make a new Mario game, and then your next game is just that again, but now you can edit it, okay? And we hook it up to the online services so that people can share their own maps. It's like Nintendo's going to make the next game, but then the next game after that is made by the user, and it's really great. And Nintendo gets all the money. Anyway, sounds good to me. I wish I was in that business position. Anyway, this is a game that is very much meant to be played, and while you play it, you are meant to die in a stage, and then you say, well, oh, that's too hard. I'm going to go back in, I'm going to edit the stage, I'm going to replace it a little bit, I'm going to tweak things. So there's this back and forth where you're playing the game, but you're also building the game while you play the game. Okay? It is almost a Lego-style magic, where you're playing with characters in an action figure or kind of doll style, and then you say, well, I need a new play set. I need a new area for my characters. And so you build it, and then you play with it, and then you build it, and then you play with it. It's a very, very nice loop, okay? For some interesting trivia, the final undefeated level in Mario Maker was recently beaten, And this is really important, I think, because Mario Maker services, I think, went offline not too long ago. So there were a few unbeaten levels that no one had managed to beat. And the community was racing in a cooperative fashion to see, can we beat them all before time runs out and the servers go offline? And they did do it, yes.
It's worth mentioning that it was fake. It was tool assisted.
Really?
Yeah.
Oh.
Yeah.
The dream is dead.
Yeah.
Dream is dead. Well, no one managed to beat it? What a shame. Okay, well, anyway, I'm going to show this to you. Someone managed to beat it. You know how I know this? Because you can't publish a map unless the creator can beat it, I think, right?
Well, the creator did, yeah.
The creator was able to beat it.
Used a tool.
Oh, they used a tool.
Yeah.
Cheated.
The creator tool, or say the creator was hiding like cheeky little dev exits in the level.
Oh, yeah, possibly, yeah. But then someone can find the dev exit and ruin the game. Yes?
The tool assist that he used, because he can't do like a task on a Switch, he modded his controller with like an Arduino so that it would run the inputs for him so that he didn't have to do it.
That almost makes it worth it. And you can imagine, well, if the creator was able to do that, why didn't any of the players do it? Right? Fight fire with fire. Yes?
Just to clear it up, the original level was cheated, but someone actually managed to beat it legitimately before. So,
Really?
So, it's a happy.
So the author, so it's a good happy ending. The author cheated, okay? And you know what you got to do to a cheater? You have to beat them anyway, right? The old-fashioned way. So that's really great. So good, happy ending. And I can just imagine all these expert Mario Maker speedrunners just all going at the same level. Now, the level's only a couple seconds long, so here's the level if you're curious. This was the last Mario Maker stage to be beaten, apparently legitimately by the community, thus defeating Mario Maker as a whole. Okay, the beast has been slain. Nintendo was good at this stuff like when we were babies, when I was a baby, okay? Right? Notice the timing there. Mario's watching, right? At the exact perfect moment to strike the pose with the music, and it's just incredible, right? That's how you know this is made by professionals. Okay, yes?
So there was a tool assisted one that beat it, and then later someone actually legitimately beat it.
That's good. That's good. So it's like the false prophet, and then the savior comes and saves us all. Great, wonderful, right? What?
There's one line icon screen. You're not the Messiah. He is. I'm not the Messiah. He is the Messiah.
Is that Life of Brian?
Yeah.
Yeah. Okay. I haven't seen that one in a long time. I just watched Holy Grail. Okay, let's get back on track here. So, this is a game that is very likely Turing complete. In that it has a finite number of objects, and those objects have a finite and a well-defined number of properties. But a couple of these objects can be used to create logical gates, which is how this whole thing starts exploding and going exponential. Pretty soon you've got computers in here, okay? And you've got entire levels just dedicated to showing you cool stuff that people didn't think they could do. So let's take a look at this.
Recently, I was wondering if it's possible to build logic gates in Super Mario Maker, and as it turns out, it is. Logic gates are some of the most basic building parts of computers, and it's possible to perform some basic computing tasks with them, like counting, storing information, or doing calculation. I actually found a way to build AND, OR, XOR, and NOT gates, which actually allow for some super basic computing in Mario Maker with some restraints. So at first we'll talk through the gates, and afterwards we'll take a quick look on some basic things that are possible with these gates, including rebuilding a circuit and building a half adder in Mario Maker. So are you ready? Let's do this! So the first gate we're going to take a look at is the AND gate. We use questionnaire blocks as inputs and output for all gates in this video. This circuit always gets activated once a P-switch got triggered. So for an AND gate, this means that this block and this block need to be set so that this block gets triggered. Our main source of electricity are Buzzy Beetle shells. This gate is actually pretty simple. Once the P-switch got triggered, this shell drops onto this spring. If both blocks on the bottom were activated, these shells trigger these blocks, which push the bullet bills upwards and allow the shell to hit this block. But if none or only one block was triggered, the shell can't hit the output. So let's take a look at the OR gate. An OR gate gives an output if one or both blocks were activated.
Okay, and just to note, like the output bit, like this block right here that gets turned on or gets turned off, it can be fed into other gates, right? So it itself is a block that you can then add other gates onto, and you can thus create very complex logic. And eventually, you can do computer style stuff. You can do calculations, all sorts of good stuff. Anyway, pretty impressive. This game, for context, came on the tail of a very long string of very uninspired New Super Mario Bros. Games. This was a very groundbreaking title. New Super Mario Bros. Came out on the DS in, I think the late 2000s, maybe, or mid 2000s. And the game was really special because it was the first 2D Mario in a long time. The series had long since moved into the 3D platformer realm, which is a very different style of platforming. Nintendo wondered if a 2D Mario could be successful along the existing 3D ones, which were also successful. The answer is absolutely, and the game sold like hotcakes. It sold crazy amounts. It sold better than the 3D Marios. So they just kept making these. It became super stale. You're going to watch this trailer, and I want to ask you how excited you are to play this game, okay? New Super Mario Bros., okay? New. Let's take a look. You know why they have to put new in the title? Because you could have sworn you played this 1,000 times. Okay? Yes.
It's so interesting to add a new game mode where you can fight against the person who plays in the blocks.
Yeah. I mean,
That's how I played it, at least.
yeah, the blocks are supposed to help you, I suppose, but anyone with the blocks can block you as well. So that was exceptionally boring gameplay. And one of the reasons the Wii U struggled is because there was a general kind of lack of new experiences that use the hardware very well. And that is a very, very derivative title, not a whole lot of innovation in it. A couple interesting things, but not too many. And so the team was forced to say, okay, well, we're going to hand all these tools over to the community and see what they can do, because we've now milked New Super Mario Bros. Formula as much as we can. When they release the Super Mario Maker and it turns into a big hit, Nintendo has a huge problem. Because now there are an infinite number of crazy creative Mario levels, and so our next Mario game, how are we going to top what people have made? And so basically, the devs took something and they decided to make this game.
Onward and upward.
So that's a lot crazier, right? The team decided that given what we've done to Mario and how crazy Mario Maker has made the 2D side-scrolling genre for Mario, we have to do crazy things, okay? We have to take our gloves off. I cannot get over that this entire game's premise is Mario and friends find some very seedy, suspicious flowers, engage with them a little bit too much, and now the world is going crazy, right? Like, children are playing this, okay? This is quite a game. But it's also a really good excuse, right? The team backed into a corner decides that this is the game where Mario is going to get voice acting. We're going to get Koopa Troopas skating everywhere. We're going to get Pipes doing the inchworm. The game gets even crazier. If you played the game, then you know. Not a lot of restraint. Nintendo is sometimes seen as a very conservative company, but they backed themselves into a corner where there were simply no options left. We have to go crazy. And they did. So it'll be interesting to see how many of the features in Super Mario Wonder make its way into the next Mario Maker, or if they even do another Mario Maker, or I'll say it's probably more likely they make a 3D version of Mario Maker. Because Super Mario 3D World, if you played that game, kind of feels like it was made with Super Mario Maker. Some of its stages are very blocky, very standardized. And underneath the YouTube comments are much higher quality than they used to be. This trailer compares to Super Mario Bros. Wonder's absolutely insane. It's not just night and day; it's decades apart, right? So they really did have to step up their efforts. A quick bit of trivia: Nintendo had a bunch of competitions to find the best level designer when Mario Maker came out, and it was won by a guy named Doug Strait, who was my president when I was Wolverine Soft vice president. So it was cool to read an article and see his name again. He was at Facebook at the time, and I had lunch with him a couple of years after when I was working at Facebook myself. So cool guy. I think he might be back in Detroit, working at Amazon Detroit office. So I'm not sure. Maybe. Anyway, it's a game engine that basically allows you to create a game while you're playing the game. You go back and forth, and you also, the way it tells you and teaches you things is really extraordinary. It's very much a game designer's engine because it just flat out does not hit you with a ton of UI. Okay, it hides a ton of things from you, right? If you grab an object in the game and you're dragging it in, the game will not tell you that you need to shake it. And if you do shake it, it will actually change what the object is. It'll soup the object up. It'll give it special properties, which you might really want as a level designer. If you took Unity and said, how can we make the act of development really surprising and fun? That's kind of what it is. So I encourage you to look at it. It's really impressive how you can just go from playing to editing to playing to editing. And hopefully more game engines will provide that kind of thing. Okay, some quick announcements before we get to the main content of the lecture, which I will not be delivering. Okay, it is my day off. And Junwen and Jacob will be tackling this. Okay, you are in good hands. They will be tackling CMake. And just a couple announcements as they get us ready here. Exam review will happen sometime next week. Maybe Wednesday, maybe Monday. It depends on if we're able to get the alternate exam finished and then executed. No, it's going to be next Monday. So it's not going to be Monday. It's going to be Wednesday, okay? Actually, we probably won't have lecture Monday because I think we're going to be doing the exam during the lecture period. Yes?
So can we not take a look at our exam and request regrades until after the exam review is done?
Yeah, on Wednesday, next Wednesday, I'll have a big cart of all your exams, and you can come, you can grab them, you can look through them, and during that period or during office hours afterward, you can let me know if you want any regrades. I got to be kind of strict because I can't have anyone going and editing their exam and then you missed this part, right? Yeah, okay. I do want you to ask for corrections there, and we can talk about it, and I can stay a bit late on Wednesday if we need to get anything fixed up, okay? Most of your grades are pretty excellent. Last year, we didn't have a lot of regrade requests at all. It was mainly just people seeing that they made a dumb mistake, and, there you go. That's the end of it. Okay, course evals. You get extra credit for filling out your course eval. We really want to give you that extra credit because we really want your ideas. We want your thoughts on the course. How is it treating you? And especially if you have any ideas for little things we can tweak or improve, maybe there's an assignment that you've got a good idea for, then we really appreciate that stuff. Because this is only the second time we run the course, and third time's the charm, and it's only going to be the charm if you give us good ideas for how to make things smoother for next year's course. I think things are going to be really nice next year. We fixed up even more little hard edges this semester. At least that's the impression I get. A lot of people made it all the way through every homework assignment. Last year, only like one person made it through. And a lot of people gave up on like homework 7 midway through. And this year, it's rocking and rolling. You did a great job. So that's a good sign. I told you about Crash Bandicoot 1, right? I already showed that to you. I'm not sure why it's showing up here again. But yeah, so okay, good. All right. That's enough of me, okay? John Wen, Jacob, you ready to take over? You want to use my laptop or yours?
Do you have a slide?
Yeah, I got them. Here we go. Yeah, and that way we can stream it as well, okay? So, yeah, you can use this, and you can use back and forth, right? So if you want to, or you can just click if you want to.
Which one is the laser?
The laser isn't going to work on the TV screen. Sadly.
Gotcha. Oh, what?
You have to gesture. Okay.
All right.
Do you want this to speak louder?
Oh, sure.
Okay, so stick this on your pocket. Okay, clip it to your shirt or your top of your jacket.
Can they still hear online if you just speak loud?
There we go. Yeah, they can. They'll be able to hear you.
Okay.
Yeah.
Hello.
And you need to flip that mute to on.
Oh.
Make it green. Right here. There you go.
Hello.
Yep.
Awesome.
All good.
So, hello everyone. Today we're going to introduce CMake, which is okay, so the schedule is 3 parts. We're going to first introduce what is CMake, why do we want to use it, and then how do we use it effectively. I'll focus more on the high-level ideas, while Jacob will talk more about the implementations. First, what is CMake? This is graphed from its official website. It's a powerful software build system, and it is the de facto standard for building C++ CPP code. But actually, I would not say it's a software build system. It's not a build system. It's more like a tool. And what does the tool do is, it first reads cmakelist.txt, just a scripting text file, which describes how a software project builds. And then, CMake tool will generate build files to actually build the project. And it supports lots of command line build tools and also popular IDEs. Can anyone give me an example of the, say, command line tools we're using in this course? Yep.
Linux and Visual Studio and Xcode.
Yeah, so Visual Studio and Xcode are both popular IDEs. What about like the command line build tool?
Make.
Yeah, exactly. So we're using Make and Xcode, Visual Studio in this course. These are what we're using here. So when we're writing CMake, we want to let IDE or build tools know our build settings. How do you achieve that? So in this course, we're basically repeating the same thing 3 times. Like we're telling each IDE or the build tool where our include directories, which files or libraries we're going to link against. Well, with CMake, what we're writing here is the very top line. We're writing some platform-independent description, and then CMake will generate various build files, which are the things we have in this course, which we used to write manually. But now we can generate it automatically. So very cool idea. This helps us to maintain DRY. Like, don't repeat yourself. Anything about, like, any question about this part?
Is anybody still confused on what CMake is and what it's doing for you? Cool. I'll take that as everybody knows what's going on.
Cool. So, yeah, basically it's high-level description of nearly everything the build system needs to know. You don't need to worry too much about the syntax here. We'll talk about that later. But the idea is we're going to say, here are some examples. We're going to let the IDE know which C++ standard we're using. We can set the standard. We can set or specify the include directories. We can also specify the libraries. So very cool. And here are our use stages with CMake. Before, we are basically writing these 3 files manually, and then IDEs will do the build stage, compile things, link against libraries. But with CMake, we have an additional stage which is called configure. Basically, it's just translating the CMake list.txt into the 3 build files. Cool. Why do we want to use CMake? So we have already mentioned one idea, that is DIY, don't repeat ourselves, because CMake allows us to do some cross-platform things, and we only need to write one scripting file or scripting text file, and then CMake will generate lots of platform-dependent things for us. It's dirty work that is automatically done by CMake. As you can see here, we have Visual Studio for different versions. These are the project files. We also have make files, say Unix make files. If you run this on Mac OS, it will also allow you to generate Xcode project. So we literally don't have to write any of these anymore. Why CMake? Second reason is popular. It's a de facto standard configuration tool for C++. Lots of popular libraries use it, say LLVM, on which your Clang compiler is built upon. And Boost library, which is a very advanced C++ library for algorithms and stuff like that. Also the Qt system. Why CMake? Because it's clear. First, enforces some kind of modular design. I saw some of you put all your source files in your root directory, which may not be a good practice. But with CMake, that won't work anymore, because CMake would somewhat force you to develop your project into different parts or different modules. So this was from my render project. As you can see, I abstract away all the low-level rendering details into a single library called base. And then users to write high-level language to refer to the base library I provide. So very cool idea, and very clear if you're using CMake. Oops. Yeah. And it also kind of forces you to organize your project directories as well. So I'll talk about hierarchy stuff later, but basically you're gonna put some source files in the root directory, but just a very, very few source files. And then you're gonna separate your third-party libraries with your source files. So it's very clear. It's powerful. It's kind of a cross-platform stuff, but it allows you to do some platform-dependent macros, because sometimes we have to do that. Say we're going to define something that works only under Windows, that works only under Apple, and stuff like that. It supports custom commands. In this course, we're copying, if you remember, we're copying some DLL files with the post copy command in Visual Studio, and you can do exactly the same thing with CMake. Here I'm compiling shaders, which is not C++, but we can still do the same thing in CMake. It supports functions, basic data structures. We just talked about a game that's Turing complete. I believe CMake is Turing complete as well. I saw someone wrote ray tracing purely with CMake. It's very slow, but CMake is pretty powerful. Any question about this part? Why do we want to use CMake? Cool. And then I'll talk about the basics, or how do we use it effectively. First thing first, it may not be an elegant scripting language. It contains lots of macros and implicit variables that you have to remember. It contains lots of legacy features for backward compatibility. So, ChatGPT could be your friend when you're writing CMake, but you have to explicitly tell him to use some modern features. Otherwise, it might give you some legacy features that you don't want to use in your project.
There's a very solid chance that if you do decide to use CMake, you will probably be asking ChatGPT for stuff, because the documentation for CMake is pretty garbage.
I agree.
They don't do it's very large and unwieldy. It's you have to control F everything you want to find, and it's not always accessible. Your best friends are Stack Overflow and ChatGPT if you're using CMake. Oh, question? Much like Unreal Engine. Unreal Engine documentation is better.
I agree.
Which should tell you how bad CMake's documentation is.
At least there are like pictures on the Unreal
Yeah,
Engine
there are
document.
pictures.
But you can't find even a single picture on CMake
Yeah.
documentation.
Unreal Engine, like they tried. It's just they tried and they didn't do very well. CMake's documentation is just like it barely exists.
I agree. Like think about you're reading the C++ standard documentation. It's basically the same thing.
Yeah.
Variability, I agree. Hierarchical structure. This is what I somewhat mentioned before. So basically, we're gonna structure our project or organize our project into a hierarchical structure. So here are some definitions. A subdirectory or directory is one containing a CMake list.txt. And so we're gonna add subdirectories using as a subdirectory command. Variables in parent CMake list are visible in subdirectories, but not vice versa. It will become clear if I show you an example. So the first thing when we build our project is that we're gonna specify the source files in our include directories. So this is the structure. Say we have a game engine, and in the source folder, we're gonna add some executable. Say we have main.cpp in the root directory. So we're gonna add that to our target. So now game engine contains a single source file called main.cpp. And then say we have other source files that is listed in a subdirectory in the source directory. Then we're gonna add more sources into the game engine target. Now the game engine target contains 3 source files or more, depending on your implementation. So these are the source files. What about the header include file? We're gonna use target include directory so this is just a variable. It represents the current directory where the CMake list is placed. So this one just translates to source. So we include, we add the source folder as the include directory to our game engine project. Why do we want to do that? Because our header files may be placed within this folder. Any question about this part? Yep.
I'll wait until further.
Okay, sure. So these are our source files, and again, this is the header search directory. Build another target. So one thing I didn't mention is how to link the Lua library against our game engine project. One option is to build through like source files. And to do that, we can target sources, like add all Lua sources into our game engine project as well. But as mentioned, that is not a very clear idea. It doesn't make your project
Not very modular.
Yeah, not modular, exactly. So the idea is to add that as a separate library, maybe a static library, and link that against our game engine project. So instead of adding all the source files, we do add library and include all the source files for Lua library in it. Then this will automatically give us a Lua library, and then we're gonna link our game engine project against it. So now the final step is to connect the targets we have built so far. As I said before, add subdirectory. It tells CMake which subdirectories we're gonna search for, or we're gonna, or like the subdirectories in which our other targets are placed. So add subdirectory, and we add Lua subdirectory into our project. Target include directories. This includes the Lua header file search path into our project. And then finally, we're gonna link against the Lua library we have just built.
You'd also, the subdirectory paths are relative to the location of the CMake list.txt that you are currently writing the code from. You can also, there's a macro that you can use to just kind of access that directory in code. Yeah.
Yep.
Like, it looks like this structure allows basically, if we have our own personal individual project and the CMake lists in it, and then we add libraries like Lua or Box2D that comes with a CMake list.txt, it's like the author of that library can write their CMake list.txt, so we just tell it to use it, right?
Yeah, exactly.
And it all works immediately.
Funny thing though, I don't think Lua actually does come with the CMake.txt, does
I'll
it?
talk about
Yeah.
in a minute.
Yeah.
In a minute.
That's a great point you bring up there.
So if you take a closer look at it, there's a subtle thing here. So in the source directory, we include the directories, the header search path, in this CMake list. In the CMake list placed in the subdirectory. But with Lua here, we are including directories in the very top level, like in the CMake list in the source folder. Does anyone want to have an educated guess about what is the reason for that? Why don't we move this line to here, to this CMake list? Yep.
Right, because those are things that are specific to the executable and not for the Lua library itself.
You're on the right track, I would say. So the actual thing is because, as I put here, the CMake list of a third-party library is often included with the library itself. So if you want to add this line to the CMake list, you're basically changing something a third-party library provides, which is not very likely to do. So we're going to add this in our personal or in our custom CMake list to include the header files from a third-party library. Does that sound clear to you? Awesome. And public, private, there are some like syntactic stuff, but so if you include directories with the private symbol, then these directories are only visible to the current target, to the game engine. Other libraries that link to your game engine cannot see those included files. Previously, we introduced ways to build third-party libraries from source, right? And like what we have done so far in this course. What about libraries distributed as binary files, say SDL.lib? We can't build them from sources anymore. So CMake provides other powerful commands. One of them is find package. So it allows you to automatically locate and integrate a pre-installed library. This was from my project. I want to include the Vulkan library, which is just a low-level rendering library as SDL, into my project. So once I do find package, so I first need to pre-install Vulkan on my system, and then once I do find package, I'll be able to see some targets. Say, as you can see here, Vulkan. So I got this target after find package, and then the thing to do is just to add this target or link against this target with my game engine. The second option is to add a DLL manually. Like you can just manually set the path to the DLL, and it will become a target, say SDL DLL target, and then you can link against SDL DLL target.
It's a lot clearer than doing it in, say, Xcode or Visual Studio,
yeah,
where the term library is insanely overused and could mean like any number of different settings that you have to scour and search for. I find it a lot easier just kind of setting this stuff up yourself. And it's a great, really way to learn how these built systems are kind of working.
I agree. One reason you might prefer add DLL manually than find package is that you might have forgotten to add this library to your system path. In that case, find package won't work because it doesn't know where a library is.
I don't believe find package only works with shared libraries. Correct? Like you can't use a find package.
I have to confirm, but I think that might be the case.
Okay.
Question?
This kind of declarative way of stating how you want a project built and configured, right? It's very standardized. You just have to do it once, and then CMake takes care of setting everything up. This reminds me almost like one for one of what you have in like the cloud industry, cloud infrastructure. AWS, Amazon Web Services, has something called CloudFormation, which is basically like, hey, do you hate going through all the nasty UI and the web console to set up all your cloud technology stuff? No, just write a single JSON file, upload it to AWS, and AWS will handle all the UI shenanigans. It will set up everything you want. It's a way of taking a big, messy grab bag of things and just kind of condensing it down to a standardized text file.
Yeah, exactly.
That is actually version controllable and easy to share and dissect. CloudFormation, OpenTofu is CloudFormation, but it works for AWS, Google Cloud Platform, Azure, Oracle Cloud. Like, this reminds me almost perfectly of that.
Yeah, this kind of like automation and collaboration is like kind of the backbone of open source development and just development in general. Like, you don't get anything done without people who really take the time to make these systems. Because imagine if every application on the planet that wanted to build on Mac and Windows and Linux had to do what you guys just did for a handful of months. It's not pretty, it's not fun, and it's not the point. Like, you want to have setup. Like, setup isn't the point. You want to actually work on your application. Yeah.
I guess there are some other options, like Lua, for example, which uses Makefiles on all platforms. But
But that's kind of weird because different. Yeah, because Mac OS doesn't like make files that are made in a specific way that Linux likes being made in this other way. Plus, in general,
Also, like,
I use
how do you
Makefiles on
you
Windows for
make file on?
you can, but there's some weird. Sorry, what did you say?
Go ahead.
You can use Makefiles on other systems, but it gets wonky. Like, for my engine, if I try and build it with a Makefile, my personal engine, if I try and build it with a Makefile and then run it, it gets really weird. Which is almost certainly something that I did. But when you're making a big project like that, stuff like that is why you have CMake.
Which is true, but I guess the one other question, does CMake have something like, say, the pip manager in Python where you can say, I want to use the Vulkan
I was
package
just
and then
about to
download
talk
it?
about it. I'll answer that in a minute. Yeah.
This may be indicative that I don't understand CMake, but when you've done CMake and all of, like, you've got your CMake lists all set up,
Mhm.
can you still, like, use the debugger in Visual Studio? Like, are you still able to, does everything just kind of trickle into Visual Studio automatically?
So
Sure.
this creates the Visual Studio project files.
Do you have to, like, anytime you add something new, you have to, like,
You have to rebuild the project files. Yes.
rebuild the project? Okay.
One good thing. Yeah, go ahead.
No, you go.
One good thing about CMake is that it works like very similar to Makefile. So any file that you didn't change don't have to be recompiled. It will automatically detect that, unless you use something called file globe, which is
Glob or
lots of people use that, but I personally would suggest against file globe. So that is a feature that automatically adds a bunch of file into your project. In that case, it wouldn't be able to detect which files have been changed.
So that's kind of awkward because later in this presentation, I'm going to recommend that you use Glob.
I know that I personally use that as well, but you have to somewhat remind yourself to rebuild the whole thing when you change some files or add like more source files.
Yeah.
And about like the release and build thing is it's one of the nasty things about CMake list. As I said here, it has lots of implicit variables, and release and debug is one of those. So it has an option to set whether you want to build in release or debug.
Yeah, that nobody's going to tell you about because again, the documentation sucks.
Yeah.
So that's what this is for.
Yeah.
That's what we're here for.
I agree, but you can manually set that. Distributed. I already talked about that. Option 3. Yeah, someone talked about pip install, things like that. The question, like a long-standing question, is: do we have a very convenient package manager for C++? And the answer is yes. We have VCPKG. Basically, a free C++ package manager for acquiring libraries. It's not like one of the CMake tools, but it can work very well with CMake. And here's a simple example that we want to install Lua and link against it. Because, as you mentioned, Lua doesn't have a CMake list. So the solution is to install Lua with CMake package. Very simple, just a simple line of command. And then you're going to integrate VCPKG toolchain into the CMake project. Otherwise, your CMake won't be able to find that library. And there are some tips of how to do that, but basically also very convenient. And the third thing is to, so until this point, your CMake should be able to know where your library is and how to link against it. And the only thing left is to tell him to do that. Tell CMake to do that. So find package Lua, target link libraries, target include header files, include directories. Same thing as before. Question? Awesome. Then we'll talk about
All right.
specific examples of using CMake in this course.
Yeah. You don't know. I can talk loud.
Oh, sure.
All right. So that's all well and good. Now we kind of generally know what CMake is, why we're going to use it. Let's talk about how you can set up your class engine using CMake. Hopefully, by the end of this section, you might be able to just kind of go in and use it. Replace your build systems with, or not replace your build systems with CMake, but you create a CMake list that works, builds your engine. Maybe not though, we'll see. Because we're going to be going over the, is it just these two buttons?
Yep.
Okay. We're going to be going over the CMake lists from my personal engine, Wolverine engine, which is built off of the class engine. There are going to be some differences. I'll go over these in a bit, but yeah. So to start, you're going to want to set up your CMake list. So you write CMake list.txt, it's just that simple. And there are some differences that you're going to want to get out of the way right away. If you're on a Windows system, you're probably using Visual Studio to compile your actual project. And so you're going to be telling CMake to build Visual Studio project files. In that specific case, there are a few things you're going to want to do. You're going to set this, the startup project name. This you don't really have to do. This was specific to my engine. But if you have any like really big files, you're going to want to tell it that it can actually use those. I'm going to set these runtime output directories. Again, you don't necessarily need to do these things down here, but you need to do this. If you're on an Apple device, there's a very large chance that you're building into an Xcode project, in which case you're going to want to set all of these properties here. You're going to want to make sure that CMake knows that you're building that, you're going to want to make sure CMake knows to tell Xcode when you build the project files that you're going to be building a Mac OS bundle. If you want to create a .app executable on Mac, does anybody know what that is, a .app executable on Mac? Do you want to tell me the difference between a .app and a normal Windows executable?
I mean, a .app, it's an executable, but it's also a bundle, and it's a zip file, so it contains the actual it contains like actual unnamed executable files in it, but it also contains a bunch of like
the resources, yes.
And a bunch of this metadata that tells the operating system who made it and its sign.
That is correct. One of the things you'll learn about me in the next 10, 20 minutes is that I really like this structure for executables. I like my stuff to be portable, and when I see a button to click that says open this application, I want to be opening the application and not redirecting to some system subdirectory and opening it from there. No, I want it to be where I put it, right? So that's how we're going to try and set up the engine. Portability is the name of the game, and we're going to get into how to do that with CMake in a bit. But yeah, basically you're going to set all this stuff. Not super important, but if you're running into issues creating your project files, you should make sure you have these set. Okay, this is the controversial part. So you're going to want to create the engine executable target. That's step 2, right? What do you need when you are building your game engine? What are the things that your compiler needs to know to build the engine? Does somebody want to hazard a guess? You've been doing this for 3 months, guys. Yeah.
What's all of your compiler's source files?
So you need the source files, and what else? Yeah.
Where to find the source files?
Where to find the headers.
Oh.
But yes, source files as well. So I am going to, this keyword here, glob, essentially just means, I don't know, is it glob or globe? I said glob because it's like kind of sticky, like it's sticking them all together, right? It's glob. Yeah. Okay, so basically what you're doing is you're taking all of the .cpp files using the wildcard thing here, taking all the CPP files at this directory. Okay, also I should say that these are using the directories and file structures of my engine. Obviously, you need to change these. So you're going to be taking all of your first-party CPP files, all the ones that you wrote, globbing them together, same with the .h's, and you're going to add the executable. So the syntax for that is, again, add executable, the project name, which you would set higher up in the CMake file, and just say, hey, these are the CPP files. It's really just that easy. Like, here's the project, here are the names of all the CPP files and the places you can find them, boom. The next thing you need to do,
Does the file parentheses, all that notation make essentially like a variable in the CMake?
Yes, so it is creating the first, that's a great question. I should have answered that. So first party variable, like a system level, not a system level, like a CMake level variable, that you can just call in the same way. It's very similar syntax to the actual, like if you go into the like Xcode or Visual Studio settings and you want to reference a directory or any kind of environment variable, it's similar syntax to that. Yeah, good question. Then you're going to include the directories. It's the same thing as in Xcode. That's header source paths or header source files or whatever, or header files. Visual Studio, similar thing. You're telling Xcode where to find, like where it can go to find the header files that it needs to link against, right? So now we've collected the source and we've added them to our executable. That is not all. If you just had an application that was files that you wrote, this would be it. You'd be done. Run your CMake list, right? Well, yeah, kind of. This would be it. You'd be done. But obviously that's not what we're doing. So yeah, target the sources, include the headers. We, in our class engine, include a number of header-only libraries. Soul is not one of them. You can ignore that. Actually, strike Soul from your memory banks. It doesn't work with the newest version of Clang, unfortunately. So ignore that top one. But RapidJSON, header-only library we include in the class, right? Very easy to do. Remember a second ago, we just included all of our headers. It's the same thing. You're including all your headers. I will also say, disclaimer, Junwon talked about modularity, or modularness. I don't know whichever the correct word for that is. You could have this. Well, actually, this you probably couldn't have in a separate CMake list, right? Because you're could you?
So there's a third keyword called interface that's specifically designed for header-only libraries.
You could.
You can build it as a C, like an interface library and link against it.
So you could also put this in a separate CMake list if you want to keep it modular. I have this inside the main one because my engine isn't really that big, and I keep it modular within the file. But I'm sure best practice is probably to put it in its own CMake list. Yeah.
RapidJSON actually came with CMake lists. So if we wanted to use the RapidJSON CMake list, would we go private with that?
So that the public-private keyword doesn't really matter if you're in your root level CMake list, right? Because like that keyword only influences what like stuff. Like if you're including like your root CMake list includes other CMake lists, then the public or private thing determines whether or not the higher level things can see what you've done. Like a public keyword in a subdirectory CMake list means the higher ones can kind of see it. Private ones mean it's only for you, if that makes sense. So this actually doesn't really matter. I have it public because that's what the documentation I found had it listed as. But yeah. Any questions on this really quickly? Header-only library is very simple to link, same as before. Just show it where the headers are, right? Cool. Okay, traditional libraries are a little different. Obviously, they have files to compile, right? A number of these will come with CMake lists. Junwon already talked about a few different ways to get them. Again, I like portability. So a package manager is kind of out of the question for me because it essentially requires people that download my engine off the internet to have these libraries installed. It requires them to have SDL at the root, or not at the root, at like on their system already somewhere. I like shipping my applications with all of the libraries in the application, right? We're going to talk about that a little more on the next slide. Okay, actually, we'll go over this first. So basically what that means is there are two different, there's more than two, but these are two different kind of ways you can link your libraries. And that's kind of a misnomer, but basically you have your statically linked libraries, which means that this library is built into the target executable during compilation, such that a separate file does not need to be accessed at runtime. This allows you to not really, this kind of makes the library part of your application. You can ship it, you can put it on other systems. You don't have to worry about whether or not the library is in the ether on their system somewhere, right? This is great for kind of like, for open source projects you're putting on like GitHub or stuff, or like products that you want people to download and you don't want them to have to go through all this technical mumbo jumbo to use. It's great for lowering the ceiling of entry, yeah.
Another benefit is licensing. So I think there are certain libraries that forbid you from linking it in statically. But I think like the AGPL is like a variant of the GPL that says, okay, you don't have to share your source code publicly if you only runtime like dynamically link to it instead of statically link.
Yeah, so there are many reasons why you would choose to do shared over static. Personally, none of the libraries in your class engine or in my engine, I think, require it being shared. But a big, like I said, a big pro of statically linking your libraries is that it's portable, which I personally value very highly in a piece of software that I want other people to be able to use just on a whim. Problem, it takes more time to link, and obviously it generates larger executable files because you're linking not an entire library, but all of the library that you are using into your executable. In contrast, a shared library, this is kind of the default setting for CMake. Target executables are linked through an external file. Linked is actually kind of not really an operative word because they are not ever technically linked. You're just kind of, the executable is just kind of shown where the shared library is on your disk or on your system, and it'll go there. What this means is that during compiling, you can make your executable, ship it off to somebody else's computer. They can try and run it, and it'll fail because that library doesn't exist on their computer. Which, yes.
And then you can do, say, what we've been doing in this class, which is you have shared libraries with DLLs and stuff, but you ship all of the required DLLs with your application.
You can also do that, but then you have to, you can do that as well.
That's what most actual programs will do. They'll ship
Yes.
their program with a bunch of included DLLs.
Yeah. So I think back in the day, memory and storage space was like, oh my God, we have to do everything possible to save this.
Yes.
These days, it's like storage is so easy and like
Exactly.
there's so much of it that some of the benefits of the shared library approach just aren't quite the same. So
Yeah, this is true. The main benefit that I identified when I was doing research for this was that it allows one instance of library, like you're saying, to be linked to multiple programs, which is kind of negates the .dll thing shipping with this isn't really a benefit you get if you do it that way. Same with the file size. Like that doesn't really lower. Actually, if you do it that way, the file size will be much higher if you're doing shared, because if you're doing it that way, you are shipping the entire library with your executable. With statically linked libraries, you are only compiling into the program the parts library that you're using. Yeah.
I've also heard that, and it kind of makes sense, when you're statically linking things, sometimes compilers can take a bit more time and do more optimizations.
Yes, that is true.
So maybe some performance improvements as well.
That is true. Yeah. So those are the main things. So now that we know the difference between static and shared libraries, does anybody have any questions on that? Because that's a big,
Why is the worst option the default in CMake?
Because it's not necessarily the worst option. And because CMake generally, as you have surely seen, assumes a level of technical know-how that every person who uses CMake is supposed to have. And so they're like, oh yeah, you can just install stuff onto your computer. Who cares? I don't really like that, so I try and link all my stuff statically. Yeah.
And then there's stuff.
Study with storage, like as a shared library, and they have this whole page and like the reason you want it as a shared library.
For what library?
SDL.
Yeah, SDL. So funny you mentioned that. SDL gave me quite a bit of trouble actually, because I was like, SDL, no, you're static, and they kept being like, are you sure? Are you sure that we're static? You really want to link us? Like, you really want to share us because we're like, it's a big library, but no. So basically, going back to the slide for a second, actually, is there a reason why I went ahead? Not really. But anyway, so sorry, for traditional libraries, really quickly, and then we'll get back to what we were actually talking about. For traditional libraries, create the library so we can link it to our main executable. Similarly to what Junwon talked about, you can use add library with the sources, very similar syntax to target executable, making that, you're just telling it where the sources are, and you're telling it where the headers are. It's just add library instead of add executable, because it's modular, and then you can link it back to your main target executable. Also, because these are technically compiled separately, you need to tell it what version of C++ to compile in. Triple check that you are actually doing this, because I spent many hours being like, why isn't this working? Why isn't it compiling? Because the other problem with CMake is that its error messages are so cryptic. There's like three error messages that you could possibly get, and none of them are helpful. So find a friend that knows more than you do. Thank you, Ravi. Big ups to Ravi. He was one of the TAs for this class when I took it. Yeah. You could also do a Junwon recommended, and I also kind of recommend this. This was my first go around with CMake, but you should probably make a new CMake list and use add subdirectory instead for all of this stuff. But yeah. So just a quick, very quick visual demonstration of shared versus static, if some of you don't quite understand it yet. Before the build phase, obviously you have your target executable that you're trying to link your library to, and your library somewhere out there, right? After build phase, executable comes with library. In reality, this should be a bit smaller because, again, you're not linking the entire library when you're doing static stuff. You are just linking the parts of it that you need. Similarly to a normal compilation, it's not compiling, it's not taking all of the bits, it's just taking the bits that actually get used. It's a very common optimization. It's just an important little bit of stuff that you really should know. Shared library, it just assumes that the library is in there. Your system will tell it generally where it is. If you're using like Brew or if you're on Mac, that's probably somewhere in like your opt folder. I think you maybe have to set that also, like you showed earlier. I can't remember what the syntax for that is, but anyway, you can look earlier in the slides.
Is it accurate to say that like if your program needs a shared library to run, it runs and then it basically begs the operating system to go find this thing for me and like give me its location?
More or less. I think that there's my guess is that there's probably something that doesn't actually make it crash at runtime. Like it probably checks that when you boot up the executable somehow. I can't imagine after all these years that they're like, no, we'll just let it crash if the library doesn't exist.
So the thing is, like, I know that in C++ you can do C++ hot reloading, like Lewis style, via DLLs and via shared libraries and stuff.
I can add to that.
Nikhil would know.
Essentially, the whole thing with this is that by default, at the time that you start running the program, your compiler will insert a few. It'll insert a few. I'm not sure if it's the compiler, the linker or something.
It should be the dynamic
when you first start running
linker.
it'll go to the operating system, to the dynamic loader, and it'll load the things.
Yeah.
Okay.
And this is stored with the executable.
I haven't really thought about using shared libraries to
Here's the
dynamically
thing,
link.
though. You don't have to do it right at when you start running the program. You can go later on and then write a line of C++ code that says, "Okay, now load this."
But then,
specific
if
shared
the shared library doesn't exist on the disk, will it just crash?
Yeah, if you try to load it and it doesn't exist, then yes, you'll crash.
That's crazy that there's not a protection for that happening on on startup.
Your protection for that is that in your code you should check first, does this file exist, and if not, then
That's true, but that feels like something that after all these years they would just make standard.
yeah. But the whole point of that is that you can use it to say load a shared library in the middle of running your program if you want, and you can also unload it and then go load in a different version.
Yeah, that's fair. I did not know about that use case for it, but that's pretty cool.
So it lets you do hot reloading, as you said.
But instead of checking that in,
What's up?
instead of checking that in CMake list, like in CPP, why don't we check that in CMake list?
Well, you can't check it, and checking it in CMake list doesn't really solve this issue because the idea is that I'm running CMake list when I'm building, the project files, but when I'm shipping the product, I'm not shipping it with the CMake list. I'm just shipping the executable.
Oh.
So but anyway, so moving on a little bit from static for shared libraries, linking SDL2. Thankfully, SDL2 has CMake list. It comes with CMake list. I don't know what I would do if it didn't, but thankfully the people at SDL are obviously very familiar with abstractions and making stuff work on multiple systems, so they thought ahead and they ship with CMake list, yeah.
Like the main person making SDL is like a hard-working Blizzard engineer, like very close to industry, very close to how people actually use this stuff when they're very serious.
Yeah. So, I mean, you can tell because there's a lot of stuff like this where it's like, oh, they really thought ahead. It's fairly frictionless. Unfortunately, it is frictionless in theory. It didn't work out that way for me because, again, CMake documentation is pretty garbage. So I didn't really, I was getting errors when I was running this stuff because, again, SDL does not like you trying to link it statically. And that's what I was trying to do. And there's not a great error message for what's going on when that's failing. So what you actually have to do is at the top of your CMake list, if you want to link it statically, which I recommend, but again, you don't strictly have to. If you don't, none of this applies. But, well, not none of this. But you should add these settings to the top of your CMake list file. For starters, if you want to link every single library statically, turn build shared libs off. I thought a second ago that it was just an SDL that this kind of, this, by the way, sets global kind of keywords that propagate across every add subdirectory, every instance of your CMake executable path thing, right? So build shared libs you want to turn off. If you turn this off, SDL will generally accept hey, this is going to be like this is going to be a static link. Okay, cool, got it. At the top, you want to turn code signing off for Xcode. Just trust me on this one. It just magically works better if you turn code signing off. I got nothing. I'm really sorry. I try. It doesn't work if you keep it on. Yeah. This actually you can completely ignore. Honestly, I really shouldn't have this one in my file at all anymore, so ignore that third one. These bottom two only matter if you have a version of SDL that is, because so on your own computer, when you're like creating the project settings, you can build it statically while having the packages installed via a package manager. But if you want, like for me, I wanted to, if you downloaded my engine off of GitHub, I didn't want you to have to separately download SDL. So what that means, what SDL interprets that as, is that's a vendor. Like if you download SDL with the GitHub repository and it's not in the package manager anywhere, it's just in the file, that's called it being vendored. And so you have to set vendor to true, or else it'll check all around your system's files except for the one place you actually have them for SDL. So if you want to tell it where specifically SDL is in your custom directory, set vendor to true for these two, but not SDL2 main or audio or image. I don't know why. Again, some of this is just magic. Yeah.
Yeah. Does CMake not do say what something like the Gradle package manager / build system in Java would do, which is for a system like that, you don't have to ship your thing with those files. Essentially, you'll say, oh, I want to use the vendor, say, I want to use SDL in this project. And then you don't include SDL with your own thing. You ship your CMake list and all of your own stuff to someone else. And then when they try to build it, it'll go, oh,
it'll download it.
CMake.
So there is a way to do that. I don't like that. Like I said, if I send somebody a file, like an executable, I don't want anything else to have to be downloaded. Maybe that's on me. Maybe that's not a great way of going about this. But personally, when I download an app, I just want it to work out the box without having to download anything extra. And so that's what this is. You could totally do it that way. I'm pretty sure even VC package has a way to do. I'm sure that you can honestly probably add. You could probably add the command line executions for that at runtime if you're like, does this package exist? If not, download it from the package manager. There are ways to do it. I just don't like it. That's personal preference. Yeah.
There's an inbuilt way to do it, and you can set it up so you also build Lua using that. I think it's called fetch content something.
Yeah, there are a lot of. This is why CMake is so nice, because there's a lot of ways to get to the same solution. It's very flexible. I didn't like doing it that way, but if you do, there's a billion different ways you can get to it. Yeah. Any other questions on any of these settings? Again, this middle one doesn't matter. Don't worry about it. Cool. We're moving on. Okay. Put it all together. Our traditional libraries. So at the end of your project file, I should also mention that CMake runs top to bottom. So you do need stuff you want to happen before in the whole process. You need higher. This is a very simple concept. I don't need to explain it to you guys anymore. At the end, you want to link all the libraries that you have. So target link libraries to your project name. If you remember at the top, we created the target executable with the project name. So we're adding to executable project name these libraries, private, but that doesn't really matter. The way that I had mine set up is I created, in the same way that we did Lua earlier, you create the library. I personally named them project name _ and then the library that we were linking. This is, again, personal preference. You can name them whatever you like. But yeah, you just kind of put them in here. You link the libraries. This static keyword, this was a while ago that I wrote this. I'm not entirely sure if this static keyword is entirely necessary because we told SDL not to even build it as a shared library, just to build it as a static library. But I have to imagine if they're there, at some point, Jacob from a year ago was like, it doesn't work without these. So again, this is just kind of black magic sometimes. But yeah, any questions on it? This also, again, all of this needs to come after the stuff that we did before. Any questions on anything we talked about before I move on to the resources folder and even more portability stuff? Wow, no questions? You guys pick up on this fast. I don't believe you, but we'll have time for questions after. Okay, portability. Again, that's the name of the game. We want games built in the engine to be able to be played on any compatible system. Problem, the game engine needs the resources folder to be in a certain spot to see it. Right now, that is in the root directory of your entire project. Obviously, that's not going to work if you want to build games in our engine, ship it off to another computer, and just let them be able to run it. This is a problem I ran into. This took up a decent amount of my time when I was setting up CMake. This is a problem you will certainly run into if you have similar issues. If you want to build for the game jam at the end of the class and you want to be able to put it on itch, you may have to solve this issue as well, or you can manually...
Game jam's dead.
Oh, it's not dead, it's not happening?
We're not doing it.
Oh, okay, changed my mind. That's not happening. But if you want to make a game in your engine, which you should do anyway, because it's a great experience, you might need to solve this issue. You can also probably do it manually, but we want this stuff to happen automatically. So, solution, you can use CMake to copy the resources to a viable directory when building the game. This was the final solution that I settled on. There are other ways to kind of achieve this similar effect. Basically, you can add a custom command. Jinwen talked about how those exist in CMake. You can add a post build command. This is kind of cheating. It's not cheating. This is the best way to do this that I found. Basically, you can copy the directory from your engine's root into, if you're on Mac, the .app/content/resources folder. So it'll be capital R resources / little r resources, because that's where when you're doing a file system stuff in a .app, it'll look in here first. Like this is the area that it'll look. There's a whole lot of other complicated stuff to make this specific implementation work. Like for my engine, I had not a virtual file system, but I added as a environment variable the directory that we want to start looking for stuff in for the resources loading and stuff. So you might want to do something like this. I don't know. It's probably not a big deal, but yeah. So post build copy directory from the CMake source directory. This is one of those global keywords that I was talking about earlier. From the CMake source directory /resources, copy everything from there into target file directory, project name / wherever we're at, resources. So we're copying it so that it ships right next to the thing. And on Apple devices, this is what it needs to be. On Windows devices, you just kind of stick the resources thing next to the actual executable, and then it's done. It's a lot simpler, but I prefer the way that this does it. Anyway, yeah. Obviously, post-build commands executed after the build. Who knew? Crazy. All right, pop quiz. Surprise attack. Bam, pop quiz. Have you been listening? Let's find out. Okay, number 1, true or false? We use CMake to build our engine into an executable across multiple platforms. Anybody have the answer for that one? Yes.
It's false. You use it to build it on different IDEs.
Ding, ding, ding. That is correct. So CMake does not build the executable. It builds our Xcode, Visual Studio, and Make project files. Very important distinction. If you didn't know that, or if you didn't pick up on that at the start, probably nothing in this entire lecture made sense. So I hope that y'all internalized that one. Seems like you did. Good job. Okay, next question. What are 2 things your compiler needs to know in order to successfully link any library? Oh, please. Come on. You got this. Jose?
The location and the library.
The what location?
The library location where all the headers or the DLL files are.
Yes. So it needs to know where the headers are and what CPP files or DLLs or sources of any kind to link.
So officially in the class, there are 4 things, right? So on the header side, what headers do you want?
Yeah.
Where should I look for them? Okay. And then on the library side, it's which libraries do you want and where should I look for them?
I've kind of bundled them into 2 different things because I, in my infinite wisdom, just kind of, you saw earlier, I wildcard everything that's in the directory, which is probably not best practice, but, you know, it works. And it also means that I don't have to manually add stuff to the CMake file every time. Every time I make a new file, I just have to rerun CMake instead of manually going in and adding it, which I think is the whole point of using CMake anyway. Yeah.
I mean, you can just wildcard your source, and then whenever you add a new third-party thing, you manually add that if it doesn't.
Well, that's true. But where to find the declarations and definitions. That's the dumb 281 way of saying headers and sources. Okay, third, I think final question. What is the key difference between a static library and a shared one? I'm going to ask for somebody else because you already answered the other one. I'm glad that you know, though.
Whether it exists in the executable or on
Where it exists in the executable or outside of it. That's exactly correct. Static built into the target executable during compilation. Shared kept somewhere outside the target executable, usually in the system files. Technically, it can be anywhere, and you can just point to it. But I think CMake likes it if it's in your like root / user / whatever nonsense you have going on in there. Okay, that's pretty much it. Final note: CMake is a great way to seamlessly. There's a bit of an asterisk in there. Build your project files on multiple platforms. It works great if you're doing Xcode, Visual Studio, or Make. Cannot vouch for the other ones, but I'm sure they work fine. I wish CMake had better documentation, but it doesn't. Yeah. Good luck.
If I really don't like CMake, are there any alternatives that exist?
I don't know.
Pre-make.
Make file on
Pre-make?
all platforms.
Yeah.
Pre-make, okay, you can look into pre-make. You can look into scans, which we showed you with Godot. That's what Godot uses, right?
Yeah.
Software construct.
You can also bite the bullet and do it all manually if you're insane.
If you graduate and you tell the interviewer that you know CMake, they'll lose their mind. They'll hire you right on the spot. Probably. Okay, most students do not know CMake. They don't know why CMake even exists, okay, or why people care about it. And so, if you can at least talk about CMake, right, and why it exists, and maybe you've done some tiny stuff with it, that will demonstrate a certain level of software engineering knowledge, experience, and maturity. And so, definitely look into it. It's one of those things you can pick up in a few days, at least at a very basic level. Use GPT and Grok or whatever AI systems of the day you want to use to kind of help you stumble through it. And that could be a really good thing for you. Everyone, the IAs put together this lecture at my request just for you. And so let us please thank them for their efforts. Thank you. Their efforts prevented me from having to go learn CMake. And so thank you very much. All right.
Also, because this terrifies me, do not take my word for any of that. Like, I've done it before, so it's useful, and this does work, but I'm not, by any means, an expert on CMake. Full disclaimer.
Okay. I said there's no discussion, but actually that was discussion, okay, for the week. So there's not going to be any discussion on Friday. We will meet 3 more times, so we do have some more stuff to talk to you about. On Monday, I'm probably going to cancel Monday's lecture because we're going to be doing the exam that day, the alternate exam for people who are sick. Yeah, I've got one final summary and takeaway lecture on the final day. I think you're going to like that a lot. The final lecture is where you'll be able to get your stickers. So you attend the final lecture, you get some stickers to prove you complete the course. And if you stick around and attend the EECS 440 showcase, which happens literally immediately after the 498 lecture is finished, then you will get some extra credit as well for enjoying some cool VR and AR projects, okay? So everyone, that's a wrap, and we will see you next week. I hope you take some time on the current assignment to actually have some fun, okay? Hopefully the work you do on this current assignment, this custom feature, is easy, breezy, and pretty fun, okay? Hopefully it's something that interests you. And remember, we're going to have a very light touch when we go to grade these, okay? So if you don't have a whole lot of time, do the best you can. And if you want to try something dangerous or risky, yeah, go for it, okay? We'll reward your efforts, okay? All right, see you later, okay? If you want office hours, come and sign up on the queue, and I'll get started with office hours in like 10 minutes, okay? All right, everyone online, thank you for joining us. I hope you enjoyed the lecture by the staff, and we will see you next time. Bye-bye.